Hello and welcome to InsideWi-Fi, Video 3. What are radio waves? Radio waves are the foundation of wireless technology, and their widespread use comes from a unique combination of properties that make them ideal for transmitting information without the need for physical wires. From Wi-Fi and mobile phones to television and Bluetooth, radio waves are an essential part of our everyday communication. What are radio waves? Radio waves are a type of electromagnetic wave with the longest wavelengths and lowest frequencies in the electromagnetic spectrum. Although invisible to the human eye, they play a vital role in modern communication systems and are widely used in radio broadcasting, television transmission, cellular communication, Wi-Fi and wireless networking, Bluetooth communication, and satellite communication. Key properties of radio waves. The key characteristics like wavelength, frequency and speed determines how radio waves behave, travel and carry information. Wavelength. Radio wave wavelengths range from about 1 mm to 100 km. This wide range supports diverse applications. Short wavelengths for high-frequency technologies like Wi-Fi and long wavelengths for long-range communications such as AM radio. Frequency. Radio wave frequencies range from 3 Hz to 300 GHz. Frequency and wavelength are inversely proportional. Higher frequency equals shorter wavelength, lower frequency equals longer wavelength. Speed. Like all electromagnetic waves, radio waves travel at the speed of light, approximately 300,000 km per second. Their speed may reduce slightly when traveling through different materials or mediums. How radio waves work. The process of how radio waves work is a fascinating cycle of energy transformation and travel. Here is a breakdown. Transmission. The process begins when an electronic device such as a radio transmitter, Wi-Fi router and mobile phone generates electrical signals. An antenna converts these electrical signals into electromagnetic radio waves and transmits them into the environment. Propagation. Once transmitted, radio waves travel through air, space, and vacuum. Their ability to travel long distances and penetrate certain materials makes wireless communication possible. Reception. The antenna at the receiving end captures the incoming radio waves and converts them back into electrical signals. These signals are then processed by devices such as radios, smartphones, laptops and televisions to recover the original audio, video or data. Common uses of radio waves. AM or FM radio. Radio waves are used to broadcast audio signals over long distances using AM amplitude modulation and FM frequency modulation. TV broadcasting. Television stations use radio waves to transmit both audio and video signals. Cellular communication. Mobile networks rely on radio waves for voice calls, text messaging and mobile internet. Wi-Fi and Bluetooth. Short-range wireless technologies such as Wi-Fi and Bluetooth use radio frequency bands to connect nearby devices. Radar. Radar systems use radio waves to detect distance, direction and speed of objects. Applications include aviation and weather monitoring. Global positioning system. GPS receivers use radio signals from satellites to determine accurate geographic locations. Satellite communication. Radio waves enable communication between Earth stations and satellites for television broadcasting, internet access and long-distance communication. The radio frequency spectrum is organized into distinct bands, each with unique physical characteristics that determine how they are used in our daily lives. Very low frequency VLF radio waves. Waves specifically in the 3 to 30 kHz range are uniquely suited for submarine communication due to their distinctive properties. Low frequency LF radio waves. Waves spanning the 30 to 300 kHz range have been historically and continue to be important for navigation due to their reliable propagation characteristics. Medium frequency MF radio waves. Waves operating in the 300 to 3000 kHz range are most famously known for their primary use in AM radio broadcasting. High frequency HF radio waves. Waves occupying the 3 to 30 MHz range are famously associated with shortwave radio for long distance and even global communication. Very high frequency VHF radio waves. Waves operating in the 30 to 300 MHz range are a cornerstone of modern broadcasting and many other communication services, notably FM radio and TV broadcasting. Ultra-high frequency UHF radio waves. Waves covering the broad range of 300 to 3000 MHz are incredibly versatile and are fundamental to many modern wireless technologies, most notably TV broadcasting and mobile phones, as well as Wi-Fi and Bluetooth. Super high frequency SHF radio waves. Waves operating in the 3 to 30 GHz range are characterized by very short wavelengths, 1 to 10 centimeters. This makes them ideal for applications requiring high bandwidth, precise directional control, and fine resolution, most prominently radar and satellite communication. Extremely high frequency EHF radio waves. Waves spanning the 30 to 300 GHz range represent the highest end of the radio spectrum, bordering on the infrared region of the electromagnetic spectrum. This band is often referred to as millimeter wave because its wavelengths are in the range of 1 to 10 millimeters. Its primary application is in high-frequency data links. Let me know your thoughts in the comments if you found this video informative and helpful. In the next video, let's see why does Wi-Fi use radio waves. Thank you for watching.